Hey, welcome back to part 10 of the Dream Home Build. In this video, we start all the way in the beginning with rough electrical and finish up with getting permanent service out to the house and the electrical all up and running. You know, you're never really doing one thing at a time when you're building a house, and when it came to electrical, that was especially the case. We really started electrical back in week number 24, and I want to say the rough-in portion didn't get finished up until like week number 41. Which is when we got, the main power hooked up to the house and the heater was actually able to run, meaning we were no longer on temporary power. But before we even started building the house, I had already spent quite some time using SketchUp to plan out the electrical for the house. In other words, I had mapped out every single outlet, every single light switch, and all the lighting in the house, and to make it easier to visualize the plan, I also drew lines between each electrical item to indicate the path of wiring. This was pretty handy when it came to running the wiring and saved a lot of wire actually. And I think it also resulted in a much cleaner installation. Of course, if I had hired an actual electrician, which I'm not, the process would have taken about a week or two according to the quote that I received. But since we were doing it ourselves, we juggled electrical with plumbing, HVAC, geothermal, and other random framing stuff. Now, of course, electrical consists of two major parts, I would say. The first one being the rough-in, where you're running all the wire and the outlet boxes, the main line, and maybe stuff like low voltage. And then the second part is the finish work, where you're installing the actual light switches, the outlets, your light fixtures, and this is like stuff you install at the end when everything's painted and ready to go. So needless to say, this video may seem like it jumps around a little bit because it does.
There's a lot of outlet boxes available. Some are PVC, some of them are fiberglass, and some of them are really cheap. And so I bought a bunch of these cheaper ones, and honestly, they're pretty decent. They're a little bit like I forget the name, but the blue colored ones. They're just a lot cheaper, so I got a bunch of them. And so far they've been okay, except for, as you saw earlier, I was getting the nails in using some pair of pliers because I didn't have enough stud space. And the box distorted a little bit. Now on the fiberglass ones, they're more expensive. In fact, they're probably about twice as expensive as the ones that were like this. But I immediately noticed that this box is absolutely sturdy. I mean, I've heard some people breaking them when hitting them with hammers in cold weather. If you can aim and hit a nail and not break anything, I think you'll find these fiberglass boxes pretty sturdy, and I've seen them in a lot of older homes. They seem to last pretty good. As soon as you put that ring in the wall, put sheetrock on it, you're probably never gonna have an issue again. Would highly recommend if you have the money to get the better box, especially if you're doing it yourself. It's more comfortable to work with. I went ahead and did all my outlets in the garage, 50 inches above the concrete floor in the front. And there's this tiny slope in the concrete so the water drains if you have any water in the garage. And I maintained that 50-inch basic measure from the actual foundation wall all the way around the garage. The reason for that, the reason they're so high, is if I'm working in the garage and I've got plywood or any kind of 4-foot wide material that I want to stack against the wall, I'm not going to hide my outlets, which is kind of annoying when you get stuff plugged into an outlet and you push something on it and it crams the wire in. However, what's pleasing to the eye is when everything's at the same level. And I can't really achieve that with my light switches because typically what's going to happen is I'm going to open the door in my garage, I'm going to walk in, and I want to grab the light switch. Now if I have the light switch 50 inches above the concrete floor, it's going to be right about down here, which doesn't really work out very well. So these light switches are going to be higher up. It won't make sense if you're standing on the concrete. It's a little bit too high. It's going to be up here. Another thing I don't like about these cheaper outlet boxes is that the little flanges on the side that tell you where to stop the outlet box, in other words, where to mount it for that sheetrock exposure, or the sheetrock reveal, they're very small. They're essentially not there. In 2x4s, they're kind of rounded on the edges, so if you actually bump this into where the 2x4 or your stud is, you're going to be way too deep. So you kind of have to eyeball these and actually make sure you get it right. But other than that, they're not bad. 25 cents a box, I mean, come on. I hope I don't regret it. If you're wondering why there's two, this is gonna be a switch for the Christmas lights or holiday lights. There's gonna be an outlet that's gonna be switched from here. That's gonna turn on an outlet for all those Christmas lights. And then this over here is just gonna have two switches, one for the garage lights and then the other one for the outdoor soffit lights. So I had a situation here where I'm installing a light box and the nails that came with this bent, and that's probably because, I don't know, maybe there's a knot in here somewhere. It's kind of hard to say. And in my experience with these fiberglass boxes, you can't bang on them, they'll break. So I carefully sawzalled the nails off and I pulled the bad nails out. And I'm using these 4-inch screws with a Torx head, and if you carefully thread them in there, it won't crack the mounts, because if you're not careful, it'll just crack. It doesn't like expand or stretch. You just, got to be careful. So I'm gonna try to do that and put them in. I'll have to put them in a little bit lower because I have the nail holes or the cutoff nails in there. So let's see if this works. So I'm not super happy with the results because it's kind of, I mean, it's a big box. It's kind of loose anyway. I might have to put some kind of back paneling on it, but this is what concerns me right here is that cracking. You can see that fiberglass molded product, it just cracks. Okay, it doesn't have any give. So, and the reason it cracks is because when you put the screw in, it actually pulls the outlet box away from the wood, from the stud, unless you push it really tight. So you just got to be careful with that. Anyway, quick solution for something that really shouldn't happen, but when it comes to these big 4-gang boxes, I don't know. I don't know how I feel about the fiberglass. Whole lot to say about the rough wiring except that you can never have too many outlets. I tried to follow all the rules and guidelines and go above and beyond. We also ran a decent amount of 20 amp circuits with 12 gauge wire, especially where I thought we'd be using larger appliances or maybe even multiple electrical devices on the same circuit. I've seen videos of people running almost their entire house on 12 gauge wire, which, to somehow future-proof the wiring, I guess, but for what it's worth, 12 gauge is slightly harder to install. It's thicker and it's harder to bend. It's also more expensive. I definitely only used 14 gauge wire like on lighting circuits. And yes, my lighting circuits were separate from my outlet circuits. This resulted in slightly more wiring, but the house will never have flickering lights when you plug in a vacuum cleaner or turn on a hairdryer. And if someone does trip a circuit breaker in a bedroom, they'll still have lights since the lights are on a separate circuit. Checking all the wiring. I was actually just running a wire from one can light, recessed soffit light, to the other side of the house, which has two more. We debated on doing this because it's kind of a waste of wire to jump like 30, 40 feet of wire across the front of the house. But I found a solution. We had a bunch of extra 14.3 cable that was left over.
and you can use 14.3 cable as if it's 14.2. You just have to make sure that you do not use that red, that that third conductor, or this. Make sure that it's not sticking out anywhere. Definitely make sure it's not accidentally plugged in. And if you don't plug it in, technically there's no energy running through it. Just again, something you don't want to forget. But this is my house, and documenting it as well as I can so that in the future, if I'm ever digging around in here and I'm like, why is this a 14.3? Well, here it is. It's labeled, and it is just a power line. Anyway, there's a lot of cables up here, or wire. There's a bunch over there. Kind of hard to see or tell what's really going on up here on the camera, but I'm just making sure everything is stapled, because I don't like loose wires. Problem with loose wires is that when they put the insulation up here and then you end up walking around trying to fix something in the future, you can trip. It's a very bad, serious trip hazard, because typically blown in cellulose or fiber, whatever that is, you can't see through it. So you don't want to be moving your feet around from one joist to another and then accidentally trip over a cable. Secondly, you don't want to trip over a cable and rip it out from where it was or damage something. So anyway, everything needs to be stapled. Everything needs to be a non-trip hazard. I'm actually contemplating on creating pathways up here in the future out of some kind of OSB, maybe 3/4 inch OSB that you use for flooring. Create a pathway that I can access the hot spots of the house, That way I can walk safely on them. I don't think you're going to lose very much thermal loss from a couple of pathways that are not completely covered. And in those cases, I could always do something more intense.
On the outside lighting, I used recessed lights all around the soffits of the house. I actually found that a 6-inch core drill bit worked perfectly for the recessed lights. And it might just be me, but I feel like recessed soffit lights on a house just give it that extra nice look. You can really get neat shadow lines across your siding, and I actually think maybe, just maybe, the wiring is easier to run because you're just running wiring right above your soffits in your attic.
Here's kind of what I did out here. We've got our 3-inch PVC coming out of the ground, which is going to have that service cable. And there's a bit of a gap here, but up here I have my meter socket, and this here is the SCU cable that goes into the house, because right behind this wall, a little bit lower down in the basement, is the breaker panel. So I just got a 5-foot piece of this. It's perfectly just enough, maybe a little bit extra on this end. And what I've done is I've actually had to sort of cut out the siding and create a block here out of trim material. This is the same thickness trim material that's used all around the house. In fact, there's a piece right there. I made sure there's flashing on top, and then I went ahead and drilled out my hole. I used a 2.5-inch bit for this, but it's actually got these little 2 bolts on both sides that tighten up the clamp. And so I notched out 2 areas in the blocking itself, that trim blocking, to accommodate for those 2 bolts to fit in. And I tightened them up before I put this on, meaning that I took this, I slid it through the meter socket box, tightened it up, and then put it back in the wall. Because there's really no other way to do it in my case. I've also got some duct putty right here on all of these screws just to keep a tight connection. I'm not sure what's supposed to happen here. I'm going to ask some people, see if I need to seal that up. It will be sealed from the inside with spray foam, but I'm certain that there's probably something better to seal it up here as well. Perhaps that same duct seal. I'm not sure. We'll find out. Of course, I got my level up there to make sure this thing was square. The only downside is I made a mistake. When I positioned this, I positioned it in the center of the joist, or in the center of the studs on the other side of the wall. So this would be in the center of the top of the panel. However, this pipe is also in the center, and I need it to be offset to go in here. So currently, they don't line up. And I could probably bend this a little bit to make it go in here, but
I might just have to create my own DIY offset fitting that'll go probably underneath the expansion joint under the meter socket.
By the way, I highly recommend doing this. Take a video of all of your wiring before you insulate your house. This way you can reference the video and remind yourself of where exactly you ran that one wire. In addition to the video reference, I also try to maintain certain rules, like all of my wall outlets were connected to wiring that ran exactly a certain amount of inches above the finished floor. So for instance, in the future, no matter what part of the house I'm in, I know that somewhere around maybe 12 or say 16 inches above the floor, there's likely a wire running there horizontally. Now here's a mistake that I made. When I ran wiring to each outlet box and each light switch box, I should have left more slack outside of the box. I think some refer to this as a service loop, meaning you have a spare 5 or 10 inches of wire inside the wall cavity in case you ever decide to rewire your outlet box or maybe just slightly want to relocate the box. Otherwise, all the wiring is stapled firmly to the studs and you have absolutely no spare wiring. I also ran a dedicated 240 volt circuit into my garage for a couple of reasons. One, I have a table saw that can be configured to run off of 240 volts, and I also thought maybe somehow in the future we'd want to charge a vehicle. So I ran a 30 amp circuit, but I guess some people run larger circuits for like ultra fast EV chargers. Oh, and here's another mistake that I learned. This is specifically about light switches. Do not install your light switch box right next to a door opening frame. When you install your door and your trim around the door, you might realize that the door trim covers the light switch box, especially if you're using larger profile trim. And I think this happened to us on at least 2 doors.
I gotta move this switch box over, and because it's too close to the inside of the wall, and I'm gonna use what's called a remodel box, which here's an example of one. This is also a fiberglass one, allied molded or whatever it's called.
Now this wiring here is for the wall oven, which will be electric, and there's also another one about 6 feet over for the induction cooktop. You can see one of the electric boxes that I ran for Ethernet cable, which is also mounted up higher, assuming we would have a wall-mounted TV in this location. Now I guess this was one of the very few locations that I did leave extra wire for a service loop. Well, this was my last look at the wiring, especially wiring on the exterior walls, because here pretty soon the insulation crew was going to come in and apply open cell spray foam on all of the exterior walls and rim joists. You can see where they had sprayed the walls and also sawed off the excess foam flush with the 2x6 framing. The only thing I forgot to do in some areas, which is not actually related to electrical, was install blocking for things like cabinets and towel holders and curtain rod holders. I actually found it relatively easy though to add the blocking later using like a pocket hole screw method with the blocking, and since this was all open cell foam, it wasn't too hard, no pun intended, to press in the 2x6 blocking. Saturday, got somebody here. So actually the insulation guys here, they dropped off the fiberglass yesterday, but they couldn't get to it probably because of the weather. And looks like they're going to be working today, so let's go check it out. On all of our interior walls, we chose to go with fiberglass batt insulation. Most of the interior walls were 2x4, but in some cases, like the garage, we had much thicker walls where they used, I think, like R38 bats or something like that. Now, the house is literally all insulated now, and I still had more wiring to run. However, this was low voltage thermostat wiring. If you've been following my house build videos, you probably know that we have radiant heating installed in the house with 8 separate zones. This means that a total of 8 radiant heating thermostats throughout the main level and the basement need to be installed. So I needed to run 18 gauge low voltage wire to all the locations that would have thermostats. And in my case, I used 18/8 wire, which is basically 18 gauge wire that has 8 conductors in it, so that you can support thermostats and equipment that uses a higher number of wires.
1, 2, 3 more zones.
What you're seeing me do here is labeling masking tape with zone names of the thermostat wire. And this area is actually going to be a future mechanical room for the radiant heat flow center, but more on that in a later future video.
Living room. Okay, let's try that again. Living room, kids' bedrooms. Of course, kids don't know that they have their own thermostat. Well, maybe when they get older. Probably doesn't help that it's 30 degrees or something like that in here. I forgot, but the basement zoning is going to happen later because those thermostats are going into future interior basement walls, which kind of complicates things a little bit. But we'll see how that works, because those thermostats that go in the slab have all of these thermostats have an optional sensor that goes into the basement slab to have sort of a reading of the slab as well as the temperature in the room. So we'll see how those are ran, but I imagine I'm gonna have to do something similar where I run 18/8 wire all the way from those future thermostats back to here to this main panel. If I hadn't mentioned in this video yet, or in these series, this is a Milwaukee stapler. I mentioned that DeWalt makes one too earlier, maybe. Very useful, saves you a ton of time. I think it's worth the investment if you're doing your own house. Not even if you're a builder or something or an electrician. Just if you're doing your own house, you'll already have a huge advantage from using this thing. I think I dropped this thing multiple times. The only downside is these little Milwaukee M12 batteries. This is an old one, for instance. When it gets cold, the battery tends to go from fully charged to fully dead and won't work. So I actually heat them up over a heater and they work a lot better. But that's a pretty common issue with lithium batteries. Newer ones are better, but still, just a heads up. Or maybe don't be like me and have one battery only that's 8 years old.
Now, for some reason, this part of electrical was the one I was looking forward to the most. This is the main breaker panel of the house, and I'm currently connecting the service cables to it from the meter socket. These cables are typically aluminum, so you need to apply anti-oxidation putty on the exposed aluminum. I'm just using an old toothbrush as an applicator. I ended up installing a sub panel right next to the main panel of the house using a 100 amp circuit. Sub panels get wired slightly differently than the main load centers, but there's a bunch of content on that already on YouTube. The biggest point here was I wanted more space for extra circuits. So the reason I think I liked this part of electrical the most was you get to stand in one spot and somehow be incredibly productive, and if you actually put some effort into it, you can get a really neat looking load center at the end. Also, after using my father-in-law's tool belt for like a year, I finally ended up treating myself to a brand new Perkins Builder Brothers tool belt, which I can totally recommend. On another note, I used one of those handheld label makers to label each circuit. This is because when you remove the front panel of the main load center, you just see like a bunch of wiring, so you're not really sure what is what. So it helps if everything is actually labeled and matches the naming scheme of how you labeled all the circuits on your load center's door on the inside. Time was flying, and the rough electrical needed to be finished up to allow the drywallers to begin their work. One of the tasks I had left to do was install nail guards, or also known as nail plates, on all of the studs that had wiring ran through them. This is so that if anyone ever tried to hammer or screw something through the wall there, they would hit the metal plate instead of running the screw right into a live wire. By the way, I found that buying these nail guards on Amazon was way cheaper for some reason than what the local stores were charging for them. I think each box came with like 200 or 250. And after this video clip here, I'm going to jump forward to after the drywall was installed and show you guys what I had to do in the attic.
So I'm up in the attic right now, doing something that, basically what I'm doing is I'm taking batt insulation, like that, cutting little squares and putting them over the recessed light fixtures. They're not cans, they're canless, which means that once we put our loose fiber insulation in here, it's going to fall through the holes potentially, and I don't have my lights in there yet. So best solution is to plug them. Now I could plug them from the inside of the house. The only problem there is you have stuff hanging out from the bottom and they haven't even mudded or taped yet, so kind of gets in their way. But by this, you are able to create like a flat surface on the bottom that's easy to work around and it's not in the way. And then when they fill this with the fiber insulation, it will just settle wherever it needs to, and the fiberglass will act as more insulation. If you're wondering how I'm supposed to seal the can lights or the canless recessed lights, well, in this case, I'm gonna have to depend on the rubber gasket, the neoprene gasket that they come with. The actual puck itself comes with a gasket that, with the tension of the springs that go into the drywall, it sucks itself into the ceiling and therefore hopefully creates a seal. They can't come up here and do, air gap sealer, because there's nothing to seal, it's just a hole. Now, if I were to wait and have them come way in the future and fill the attic with insulation, then yeah, I might have my lights in by then. Only downside to that is we need to heat the house for various reasons, for priming, painting, for drywall, mudding, and taping. And it's really, really difficult to heat a house that has no insulation above the ceiling. It heats up, but you're throwing away a lot of heat. You're essentially going to be melting the snow off the roof because all it is drywall. What do you know? Well, that there is a meter. That means I have power. Sticker's a little bit crooked. Actually, the meter itself was crooked too. Well, I guess it means I can have permanent power now. Also, that means I'm assuming that nothing went wrong during the install. I guess for some reason I get to have this green box. I don't know if it's a junction box of some sorts. I don't think any other neighbor has these. So, yeah, I'm a little confused, but it's coming up from the transformer into this maybe junction box. And then it runs underground to another pedestal, which is because it's past 100 feet. So I think it's a voltage drop that they're trying to avoid. Первая розетка во всем доме, которая питается от... О, не работает.
Не работает.
Я пошутил сейчас.
Ах ты.
Заработала.
Работает, да?
Mm-hmm. Mechanical room power. Dedicated breaker, which is actually on a sub feed right here. 20 amp GFCI. Ой, осторожно, осторожно, осторожно.
Откуда оно?
Да, я наверху оставил.
На лестнице стояло.
Ага. That's okay. Lifetime warranty. Работает.
Well, if you've made it this far, I hope you enjoyed the video and perhaps learned a thing or two from my experiences. In the next video, I'll probably be focusing on the drywall installation and my overall experience with hiring a crew to do the drywall. If you're wondering how I wired up the geothermal units, I covered the wiring in the previous video where I also talked about the entire geothermal installation. Check it out.